Good morning again. It's Victor Diaz-Seco from the European Maritime Safety Agency. Now I will give you a presentation on the response to oil and hazardous and noxious substances, HNS pollution incidents at sea. We will start with the oil spills at sea. Initial considerations are that oil floats. There are different types, from diesel to heavy fuel oil. Lighter fuels produce more vapor, more harmful to humans. Oils can be redistributed on each tide when they reach the shore. It's a hazardous waste that can be recycled and reused, and they represent a risk of fire or explosion at the shores. In the initial assessment and evaluation of an oil spill, we have to focus on the benefit that we can get from the response. As we saw in the previous slide, spills can be from a vessel, it can be from an offshore installation, it can be from a shore facility. So we have to do an initial assessment and evaluation on the response strategy that we can follow. And here we have several options. We can observe and monitor. We can go for mechanical recovery. We can go for the application of chemical dispersants for in situ burning. But why and when and which are the pros and cons on these options? If we start with the option of observe and monitor, which is, apart from an option, something that we have to do always in an oil spill, because these options can be applied individually or they can be combined. We have several systems that can help us in getting a good situation awareness, starting from oil leak detection systems, which are radar-based and based on board of the vessels. We have Earth observation tools from satellites. We have aerial surveillance means, and we have also drones or AirPads, remote pilot airborne systems. These provide us with a good picture on what is the pollution, what are the boundaries of the pollution, what is the extension, what is the type of the pollution. We can also go a step further and try and do a simulation of trajectory and behavior of oil spills with some modeling tools. There is also the possibility to deploy drifting buoys in order to support in this assessment and see what the oil is going, where it's moving, or how we can predict where this will move. With that, we can elaborate our response strategy, and we can then initiate the actions that we saw in the previous presentation in the contingency plan. Once the strategies have been agreed, to implement the contingency plan on the basis of an assessment of the situation. The first option that we can consider in the response to an oil pollution incident is mechanical recovery. Mechanical recovery consists of physical barriers that we place in the water to contain and collect, and then mechanical devices to redirect and remove the oil from the surface of the marine environment. Most common mechanical recovery systems are booms, skimmers, sweeping arms, combined systems, nets, all of them to contain, collect oil from the sea surface. We may deploy these systems from highly specialized vessels with a large storage capacity, like the vessel that you can see on the picture on the bottom right in the slide. This is one of the vessels that the European Maritime Safety Agency has contracted in Europe to assist the member states, European member states, in the response to pollution incidents. Or we can do the deployment of these mechanical recovery systems from other means. It can be deployed by non-specialized vessels, vessels of opportunity, boats when it's near shore, or even from the port or from the beach. It's important to bear in mind that mechanical recovery operations are always linked to what we call a mechanical recovery cycle. So we start with the containment of the spill, recovery of the spill, loading in a vessel or a device that allows to take the oil from the water, storage of this oil and water mixture, eventually with debris that may come with along with the oil. There is also the possibility of in specialized vessels of the decanting of the sex of water. So we discharge the water and we maximize the efficiency of the response operations because we only storage the oil that we have recovered from the sea. Then we should discharge this oil import to a reception facility. This is something also to be considered in contingency planning, which reception facilities are or might be available in order to receive the oil that has been collected at sea. And last but not least, cleaning of all the equipment, systems, and vessels that have been used in this mechanical recovery and waste disposal. What are we doing with all of this waste that is generated? Oil, debris, all that is being collected from the sea or from a beach, when the oil can be mixed with sand or any other products. So waste disposal is a challenge, and it's also an issue that we have to consider in this mechanical recovery cycle. To illustrate a bit more on the mechanical recovery, we have offshore equipment, the equipment that is used far from the coast, which is primarily comprise booms and skimmers. You can see in the picture down left in the slide how a boom is deployed from a ship. It's a large capacity or recovery ship, and if you pay attention, you may see one skimmer that is moving to the patch of oil. So we have one boom, one offshore boom that has been deployed from this vessel, is being pulled by this assisting tugboat, and in parallel, there is the deployment of this equipment. So the boom plays the role of containment, and the skimmer plays the role of recovery once it will reach the oil spill. You can see in the picture down on the right the detail of one offshore skimmer. These are floating devices, which main parts are floaters, propellers, eventually, a skimmer umbilical, and pumps. Of course, they require of ancillaries like power supply, storage reel, crane, and there are of different types. Brass skimmers, which are oleophilic brasses, which selectively recover oil and not the water. which is put in a collection chamber inside, and then with a pump transfer on board of the ship or oil recovery ship to store and process this oil before it goes to port and is transferred to the reception facility. If we are considering equipment for near-shore response or response in shallow waters, of course, the dimensions of the equipment will have to change, because not a big ship can reach waters, shallow waters or waters near shore. So here I wanted to illustrate a few examples of equipment which is available from the European Maritime Safety Agency for the response to oil spills in shallow waters. For example, working boats with oil recovery capabilities. This is, for example, a working boat which is equipped with a skimmer and a small sweeping arm for the collection and direction of the oil to the skimmer, which is placed in a side cassette on this small boat. Then the storage is in these boxes here. And one of the beauties of this boat is that it can be only shipped by plane. We will have a different type of booms, because in this case the booms will play a role more to confine an area where the oil can be collected then from small skimmers. And just to give you another example, some other tool that could be useful in response operations near shore is the use of storage barges, because in the absence of oil recovery vessels or large recovery vessels where you can pump oil collected from the sea, you have to think about any other possibilities. One is the use of floating storage barges, where you can fill the oil that is being collected in shallow waters or near shore, and then take these barges to shore again to discharge to the port reception facility. We cannot go in this presentation in detail of all the systems, but my target was to illustrate some good examples of equipment for the response offshore and near shore. So why mechanical recovery? It is clean, because what we are doing is to remove from the environment the oil for disposal at appropriate facilities. We don't add further pollution to the environment. It has an extended time window, because you can collect the oil from the time that was released until few days. Of course, when it gets too emulsified, it gets difficult, even the collection by mechanical means. But it has a limited weather window. So with rough seas, all of these systems cannot work, as you can imagine, in open waters. And somehow is a task that requires certain expertise and training. Another of the options that we can consider in the response to oil spills is the application of dispersants, what they call chemical dispersants. Although the last generation of dispersants, in terms of chemical components, is very limited and very light. They have been improved a lot over the time, and in order to become environmentally friendly. Nevertheless, the application of chemical dispersants by aerial means or seaborne, because you have the two possibilities, will require always an impact, spill impact mitigation assessment and prior approval in the contingency plan. You have to consider where dispersants could be applied so they don't pose a risk to the environment, because what you are doing with the dispersants is that you break out the oil spill in many small pieces of oil, but this then goes down to the sea bottom. Then with the time, this is dispersed over the years, but in principle, for example, I can tell you that dispersants are not recommended in shallow waters because they can create too much pressure to the environment. For an effective treatment, the dispersant must be applied to the oil as soon as possible within the window of opportunity. That means while the oil is still dispersible and not affected by the weathering process. When the oil gets emulsified, then the dispersant starts to become inefficient. Inadequate quantities and by means of suitable spray pattern to obtain a uniform distribution of the dispersant over the oil and a suitable dispersant oil contact. There can be some reasons why the dispersion is ineffective. It can be due to the nature of the oil. For example, if, as I said before, if it has weathered too much, then it's not dispersible anymore. It can be to very low or no weight energy at sea. So when the sea is too calm, the dispersant is also inefficient because the dispersant needs some agitation in the sea in order to break this oil into many small pieces. It's not only that the application of the product facilitates that, but also it requires the sea movement, and therefore when the sea is too calm, then the application of dispersants is not recommended. So then it's important also to consider the quantity of required dispersant to be used. Normally, what is called the dispersant to oil ratio is within a range of 3 to 10% dispersant as volume of the equivalent oil. So 1 part of dispersant to 10 to 30 parts of oil. So that means that if you apply 1 ton of dispersant, then you could disperse from 10 to 30 tons of oil. And if it is an optimal dispersion, 10 to 30 tons of oil will disappear from the sea surface and will be dispersed into the marine environment. Again, I have to stress also that application of dispersants is what requires of technical expertise and capacities. The last most common option in the response to oil spills is the so-called in situ burning. How we do that? We go to the oil spill, we deploy what we call fire booms, which are special booms with a special construction which is resistant to fire for a period of time. It can be up to 4 hours. And as you can see in the slide, it's not a common boom. It has a high temperature resistant flotation center, stainless steel kinetic mesh, stainless steel component retention bars. I mean, it's quite heavy built boom to resist fire for a period of time. The tactics is that once the oil is confined, then through igniters, you will force the fire. And then with this technique, what you are doing is basically to transfer the oil that is in your surface to the environment. So is burned and moves to the air. Of course, it doesn't look, when you see a picture of an in situ burning operation, environmentally friendly, but it is something that might be considered in the response to a large oil spill, and depending on the location of the oil in particular, because if you have an oil spill near shore or in vicinity of a port or of population, of course, this is something that you will never consider, but as part of the toolbox, it could be an option in certain circumstances. For example, I remember in the Deepwater Horizon in the Gulf of Mexico in 2010, this was one of the techniques used in the response to that massive oil spill. But of course, it will require a spill impact mitigation assessment to see or to compare the benefits with the risk or the damage to the environment that may cause, and prior approval in your contingency plan. This is not an option that you will consider when you implement a contingency plan in response to an oil incident, unless you have it pre-agreed. When we go to shore cleaning, this is something that is, it requires a lot of manpower and a lot of efforts. And this is something that you will face when the oil reaches the shore, and then there is no other way to recover the oil from the shoreline. We can differentiate here in three different stages. The first one is emergency phase, when the oil is floating. Then you will get the oil stranded. And the third one is the policing phase is required. There are different techniques to be applied. What will depend on the types of the shoreline. It can be ports, rocks, some beaches, muddy shores, corals, mangrove. There are different types of equipment that could be used, like booms, pumps, vacuum trucks, and skimmers. If you do mechanical collection, you will need heavy machinery. In some areas, you will have to face a manual removal because there will not be any other means to reach that place, or maybe you don't have such resources. Flushing and self-washing due to the waves. Sometimes natural cleaning helps and play a good role. Some pressure washing machines with or without chemicals can be used, in particular in rocks and such environments. Some sewing and batch cleaning machines, hand wiping, and bioremediation. I mean, it's plenty of techniques. I will stress that in terms of shore cleaning, the main challenge is that you will face a complex logistics and, last but not least, health and safety issues. You will need to access the coastline with heavy machinery, storage tanks, etc. You will have to provide food and shelter for cleaning operative, provide with personal protective equipment, and conduct proper health and safety risk assessments. So either for responders or volunteers, they are working in a safe environment, and plan for a sound waste disposal, which should be environmentally friendly. But this is costly and can be difficult, and in particular in the case of hazardous substances, especially when you are doing with chemicals or hazardous and noxious substances, which may be part of this spill. So I hope this can provide you an overview and at least to foster thinking ahead on the different challenges and that you would face and that as much as possible should be contemplated in advance in your contingency plan. I wanted to show you that operational services of the European Maritime Safety Agency in this context. As I explained to you before, our agency has different objectives. One of them is provide support to the member states in the response to pollution incidents. So we act as a tier 3 in tier 3 incidents, as international support to all the European Union member states, for which we have a strong toolbox comprising 17 large oil recovery vessels, 10 of them equipped with small drones. We have 4 equipment stockpiles with a broad range of equipment that can be provided to member states for the use in the response to incidents from their vessels. We have 8 dispersant stockpiles, and I mean, it's a full service at the disposal of the member states. Moving forward, going to the challenges of the response to HNS incidents. The Oil Pollution Response and Cooperation, the HNS Protocol 2000 on response and cooperation to pollution incidents by hazardous and noxious substances, is the main international instrument for the cooperation in response to this kind of incidents. HNS are defined as any substance other than oil, which, if introduced into the marine environment, is likely to create hazards to human health, to harm living resources and marine life, to damage amenities, or to interfere with other legitimate use of the sea. Normally, HNS products are chemicals, but not all chemicals transported by sea are considered hazardous. This is important in this discussion. We may have chemicals or HNS products in ships transported in bulk or in containers. HNS incidents are unique and very complex by nature. While it's impossible to have a contingency plan for all HNS substances, so which make it more challenging. The main challenges in the response to HNS incidents is that you will have a substance release or leak, which may float, vaporize, sink, dissolve. It can be a gas, because the physical properties of these chemicals vary a lot. There can be a fire or an explosion that may compromise the structure of the ship and lead to the release of substances on board. And if in addition there are potential hazards of interaction or reaction between substances on board, like be the case on board of container ships, where you have a broad range of substances being transported on the same ship, can lead to an escalation of the incident. In an emergency, 3 basic steps that could be followed in the response to chemical spills would be: first, the identification of hazards and risks. That we start with the identification of all the substances and cargo that is on board, which is very often a challenge. The location, there might be miss or non-declaration of dangerous and polluting goods. We may have problems in accessing the cargo manifest, or the cargo manifest can be wrong. So this first step on the location, it can be time consuming, but is very relevant. Once we have identified the substances, we should gather information on the hazards, the physical behavior, if it is a gas, if it is a liquid, and the physical and chemical properties of each substance. Because with that information is when we can start to move to phase 2 on the prioritization assessment of hazards and risks through an analysis of all the information available and prioritizing the hazards considering the potential risk. Once we have done that analysis and we have a clear picture on what are the products on board that vessel, what are the hazards and what are the risks, and we have completed an assessment, then we can initiate a response action. And as to illustrate some examples of response options to HNS incidents, I have prepared this table. For example, if the HNS type is toxic gas or smoke plume, one response option could be changing the position of the vessel with regard to a wind direction so that plume moves away for windward areas, for example, boarding area for response crew. In case of packaged goods, ship-to-ship transfer of packaged goods, packaged cargo removed from the casualty that requires a vessel equipped with lifting gear, lorries, etc., or especially salvage platform with similar capability. In the case of a gas, there can be a control release with sprinkler systems, knockdown, with incorporation of a sprinkler system to produce water-air combination that reduce concentration and scraps material from air due to entrapment of material in water droplets. We may have hundreds or thousands of situations where we need to assess what is the risk, what is the product, and then to come up with the right response option to that incident. Thank you very much for your attention, and I remain available for any questions you may have on my presentations.